paid for itself in a week. That. So that was one. And that project actually started me thinking. And we were also trying to explore. See, in the early days, and I know Stephen Giff is here. All of us started in electronics, and we were adamant that we have to get electronics. This is island of ours. It took us a long time to realize that that is an area that you have to get into very, very carefully. Extremely high risk. We were talking about making ICs and all that, and we realized very quickly, hey, IC companies are being born and they're dying every year in the US. So for the trying to build, that big risk means you'll sink if you get in that area. So there was a wake-up call that came with this project that told me, okay, we were actually trying to find a sort of an optimum solution. I mean, you can't kill electronics in me. I've been doing electronics since I was age 12. But we're trying to find a middle ground where we could do some electronics and make it productive and useful and, and get some income from it, yes, and all of that. And this was looking for that medium, but as I said, wake-up call. This was an exciting product as well. This is the scoreboard and the Queen's Park oval. It had, in fact, in the middle of it, room. This was taken before the LED board was put in. A lot of people complain because, oh, the board not bright and so on. Well, the truth of the fact is I had to pay for it. And at the time when this board went in, there's my colleague, Emil Aparali. That's his car sitting right here. At the time, the boards now, I don't know if most of you realize this, those of you in physics would know, if you look at the TV, TV has red, green, and blue dots, and by drawing the ratio between that, it gives you the impression of color. But in those days, these boards only had red and green. Used to try to trick you to see blue, so it couldn't go perfect white. At the time when we did this, while we were erecting the board, the technology came for blue LEDs, which are still a bit expensive than red and green. But the price of those boards was like 3 times the cost of this one. So we decided we have to go with it. At the same time, my colleagues in Aparali, Dennis and Anand, under the stewardship of Professor King, wrote software called Scocon that would do all of the cricket scoring on that little LED board. It's still around somewhere. But the board was different because it was the first time, what am I doing? It's the first time that the board had so much statistical information on an electronic board. That I did not do that. So much statistical information on it. These were all alphanumeric displays that would display every single batsman, every single bowler on the team. Each column was for a particular team. And actually, you could actually play back a whole game on those displays. So it was a pretty powerful board. It wasn't all that expensive after we built it, that's when we realized it. But it was the first. I checked around. It was in fact the first of its kind in the world. Now everybody has gone strictly to LED boards because they are much cheaper, and of course they're much more flexible. But that was one heck of a project. This was like probably 12 o'clock in the night putting on panels on this thing. We believe these guys, one of the companies came and they said, look, instead of riveting these panels, that's the black section on the board, why don't you use this double-sided tape instead? And we did it. The product about this, I started my work in PAN, which began, I was motivated by working in the labs. The then head, Dr. Ashton Paris, had me teaching a course called Industrial Instrumentation. And at the same time, there was a technician by the name of Tessie Julian, who's now living in the States. He was a car Tokyo man. He was talking about all the problems they had with amplification and so on. I said, amplification? I used to be a DJ, right, on campus. My name was Party Heat Inc. But we were good. I soon realized that the stuff I was doing in instrumentation could be applied to PAN. What is a PAN? But essentially, when you strike it, it vibrates. And there are tons of different ways that engineers in the industry know to measure the vibration of vibrating metal. It wasn't hard to put the two together. What was difficult is dealing with the PAN. All right? And that is one thing I started. And I have to say at this point in time, what still eludes me is how to properly amplify the way we were doing it. And this is one example here, a tenor PAN. Because it is so extremely complex. I had to put my work down and start digging in the books. I asked for help, and I have to say this. University is a nice place, but you meet some nice, not so nice people. But then there's a slice of life, right? One of the lecturers I approached, then said to me, I said, look, I'm having this problem amplifying bands. We're using direct sensors, which, I'll use the mouse, even I will help, which are these here, these examples of it. This is not unlike, actually, the pickups you use on a guitar. And in fact, Tony Williams is the one who cued me on this one. We use other methods. There's also a magnetic type sensor. We use contact type sensors as well, piezoelectric, as they're called. They're not very, very popular among guitarists. But we would be in a hit and miss situation. Sometimes it would work really well, and sometimes it'd be like, well, I don't know if anybody ever tried to operate on a cat while it was alive. It was really bad. And we realized it was because all of these resonances in the pan, some of them are trapped inside. You can't hear it. When you put these sensors on, you bring them up. And all hell breaks loose. So we could not consistently, even to this point in time, do electromagnetic or piezoelectric or any type of direct, this is microphone free, pickup method for the steel pan, for the tenor pan that is, without getting into these types of problems. I realized it was a vibration type problem, but I asked the lecturer for help. I wouldn't call his name, and he said, quote unquote. And this stunned me. He said, will there be any papers in this? And I said, well, maybe, I don't know. He said, well, if there's not, I'm not interested. And I said, okay, who's paying you again? University was saying, who's paying them? Government trying to pay you, who's paying them? But that was it. That was more than 20 years ago. And that sort of kind of set the tone for me, because I felt that if you're working here and if John Public is paying you, you need to give John Public something back in return. So I plugged on my tuners then, trial and error, because I learned some of the vibration stuff, but we still haven't been able to crack this one. And in fact, to really solve this, you have to do some very radical things with the steel pan. But there it was, 1987. 1987, we started this journey with respect to amplifying the pan. These pans were done for Copeland Steel Orchestra, of which I am an honorary member, proud to say. Band hasn't done very well over the years, but they did in fact launch, it's a very bad shot of it, it's taken off my TV off a bad video, so I have to apologize for it. It was in fact launched in July of 1987, the same time I was heading to do my PhD. And it sounded very, very well. I was quite surprised. In fact, I just stood up and said, well, you want to hear this, and you're going to hear that, and hear the other, and you wouldn't like it. But this is a work in progress, and it's also familiar. And then this was in Laventille. Car Tokyo, I ran up the hill to change my clothes because I was supposed to give speech, but my minister coming and all that. And I came back, all of the Despers were down there. And I said, oh, all right. And then they started to play, and I could not believe what I heard. It was absolutely, absolutely heavenly. The basses that we use, this is a bass, it's 18 inches long. Because when you amplify the way we do, not with a microphone, you do not need that skill. This bass would play in space. I could carry it in the airless space. If I could run a long wire down to earth, you will hear it. Because it's directly picking up the motion of the steel. That's exactly what you hear when that sound comes through the air. Okay? So we could have done away with the long length skirt, so all issues of portability, we saw it being reduced and so on. But even as we touched this bass, we saw the problems coming up. Again, we saw the need for mechanical engineers, metallurgical, sorry, I recognize Professor Copeland in there. He wouldn't let me forget if I didn't mention him. You know him, right? He said. But this is one of the pluses we had, and in fact, I would say the electromagnetic methods we had worked very, very well on the bass. This bass that we had here, the first speaker we ever bought for the product. First time, first note, boom, speaker went out and it stuck. All right, lots of power. right? Lots of